Chapter 10, Forecasting, Segment 6, which is also the last segment. We are not going to spend a whole lot of time talking about weighted moving averages. It's just a variation of moving averages. The real difference is that you say, the older data is more important than the newer data, or the newer data is more important than the older data, and you assign it a certain percentage. If you thought the last month's information should have more importance than the 2 months ago or 3 months ago, you might assign it 60% of this number, 30% of this number, and 10% of this number to come up with your value. If for some reason you're trying to deal with something where you think the older data is more accurate than the newer data, let's say it's maybe a little bit more cyclical, you might say, let's go ahead and just give 10% to the last month's, maybe 30% to 2 months ago, and 60% to 3 months ago. Of course, you could have a moving average of 5 or 6 or 8 or whatever numbers you want, just like you would with moving average. But the weighted, you just are trying to also figure out the percent to apply to each one to give you as accurate of a forecast as possible. So let's take a little look at what this looks like. So here we are. I'm going to make this a little bit bigger. So this is the same problem. All I'm doing is, and I just rounded these to the nearest whole number. So if I took a no weight, I would say October I should run 200. If I thought that the September demand was more indicative of what I'm going to be doing in October, I might say let's apply 60% to September, 30% to August, and 10% to July. Of course, this could be 70, 20, and 10, or 55.7, and etc. Okay, again, just like in moving average, if you're using weighted moving average, you would play around with these numbers and with past data until you found out what forecast weighting closely matches your actual demand. All right, let's just say for argument's sake that in October we ended up at 205. Then that tells me that strangely enough, the no weight one says in November we should run the same thing we did in October. If you did a weighting in which this October's was more important and this one was less important, you'd say run 204. If you thought the old data was better than the most current data, you'd say run 207, because this 210 is saying I'm giving 60% of my value to that number. And so that's how that really plays out. All right. For the weighted average, the sum of coefficients always equals to 1. Why? Pretty straightforward. 60% plus 30% plus 10% is 100%, or in decimal form it's 1.0. That's just the way it works, right? You can't say I want 110% of that candy bar. You just want 100% of it. All right, moving on. Safety capacity. What is safety capacity? Safety capacity is simply you may have the ability to run more in a given period of time, capacity, than you are currently running. So let's say that you currently can run 200 units a day. You may have some idle machines that if you started using those, you might be able to run 250 units a day. So you'd have a 50 unit safety capacity, which is a really good idea. The reason it's a good idea is if you have a bump in your orders, you don't want to have to be scrambling to go buy new equipment or hire some people right off, off the street with no training. It gives you just the ability to produce more should you have the need to. We have time series forecasting methods. We've already talked about the moving averages. My question to you is, which method is excellent for short-term accuracy? So I go up here and I say, here's accuracy, here's short-term. Nope. Better. Oh, better. Very good. That's what we want right here. We want to use the Box-Jenkins method if we were doing that. So not a big one here. Causal forecast. And then I'll tell you, on quiz questions and exam questions, I oftentimes like to change that from causal, which means what causes something, to casual. So pay attention to that word right there. Make sure you read it and not just glance over it. All right. Which model is useful where strong cause and effect relationships exist? So we say, okay, useful where strong causal relationships exist. Let's use regression, which is just the best fit line, is a more simple layman's terms for that. Okay. And guess what? We are done with that. All right, that concludes Chapter 10.